This video is about multiplying and dividing complex numbers. All right, so let's get down to the nitty-gritty on this one. So multiplying complex numbers works about the way you would think it would. So what we were doing before was we were adding the A values, adding the B values. We're treating them like binomials, and that's kind of what we're going to continue to do here. We're going to multiply them as we do binomials. Just like we did when we were distributing, if we were doing, 2x plus 1 times a quantity x plus 5, something like that. So we're just going to basically be distributing if we look at it in the grand scheme of things. So what I'm going to do, let's go ahead and do A kind of off to the side here, and I'll show you what I'm talking about. So let's do our first piece, which would be 6 times 4, so that would be 24. We've got 6 times negative 7i. So 6 times 7, that would be negative 42i. Now we're going to do 5i times 4. 5 times 4 is going to be 20. So plus 20i. And then 5i times negative 7i. This is the one, this will ever catch up. This is the one that's kind of weird. 5 times 7, we'll go ahead and do it the long way. So 5 times negative 7, we'll say is negative 35. And then I squared. The question that we do with the I squared. So if we combine all this together, we get, let's see, 24 minus 42i plus 20i. Now that I squared turns into basically a negative 1. So 35 times negative 35 times negative 1 will be positive 35. So we'll add that on to the end. And now we can collect our like terms. So let's see, 24 plus 35 would be 59. And then negative 42 plus 20 would be negative 22i. And then here's our solution. Let the internet catch up here for a second. So we're treating these just like any other binomial. It does take a little bit of space. That's all right. Let's go ahead and do B. I'll go ahead and do it off to the side. So this was A. We'll do B over here. And B says 2 minus 3i times 3 minus 2i. So we're going to do the same kind of distribution. Come on, internet. We're going to start by multiplying 2 and 3. Okay, 2 times 3 is 6. 2 times negative 2i will be negative 4i. Negative 3 times 3i will be negative 9i. And then negative 3i times negative 2i will be plus 6i. Let that catch up. I don't know why it's going so slow all of a sudden. I'm sorry, guys. My goodness. Here it comes. Come on, you can do it. All right, so I'm going to do the same thing with that, and this should be 6i squared, I'm sorry, at the end. I'm going to take that I squared, I'm going to turn it into a negative 1, and 6 times negative 1 will be negative 6. So I'm going to rewrite this as 6 minus 13i minus 6. We'll put those two constants together, the 6 and the negative 6, and I'm left with just negative 13i. My goodness, I'm going to check my connection here in a second. Go ahead and do C. I'll do it over in that kind of gray graph area. We'll do C over here. And C is 5 plus I. And then 5 plus I. So what I'm going to do, same as before. 5 times 5, 25. 5 times I, 5i. 5 times I, 5i. Then I times I will be I squared. I'm taking that I squared, I'm going to convert over to that -1 because I squared is -1. So that's 25 plus 10 i's minus 1. So we get 24 plus 10i. There it goes. Before we get into division of complex numbers, we need to talk about an idea called a complex conjugate. So if I have a plus bi, its complex conjugate will be a minus bi. And this has some kind of interesting effects. So let's take a look at that a right there. So what I'm going to do is I'm going to multiply that by its complex conjugate, which means I'll be multiplying 2 minus 9i times 2 plus 9i. And that's really all it means, is you're going to swap the sign that's in the middle. Okay, so 2 times 2 will be 4. Negative 9 times 2 will be negative 18i. Oops, I did that backwards. Me being bad at keeping track of things. 2 times 9i would be 18i. Negative 9i times 2 will be negative 18i. And then 9i times 9i will be 81i squared. Oops, minus 81i squared. Okay, so we're going to take that 81i squared. We're going to convert that I squared into a -1, so it'll be plus 81. So 4, our 18i's kind of cancel themselves out, and we get plus 81. So our final solution will be 85. So notice how the complex conjugate kind of got rid of my complex numbers. Let's try it again for the next one and see what happens. So the complex conjugate of -5 plus 2i would be -5 minus 2i. So let's go ahead and write that, -5 minus 2i. -5 times -5 will be 25. -5 times -2i will be 10i. 2 times -5i will be minus 10i. And then the 2i times -2i will be -4i squared. We're going to take that I squared, convert it to a -1. -4 times -1 is going to be a positive 4. So the i's cancel out. We get 25 plus 4. And our solution here is 29. So again, the idea of a complex conjugate is going to be our original term is a plus bi. Our complex conjugate will be a minus bi. And this is really important when it comes to division. Let's give it a shot down here with b. And I'm going to go ahead and work over to the side here. Scroll there on my tablet. So let's look at b. 5i divided by 2 plus 3i. So what I'm going to do is I'm going to look at my denominator, and I'm going to be multiplying this problem by its complex conjugate. So I'm going to go ahead and rewrite the problem. 5i over 2 plus 3i times 2 minus 3i over 2 minus 3i. Now, if you think about what I did, I haven't really changed the problem because 2 minus 3i over 2 minus 3i is a form of 1. So what I'm doing is completely legal, and it's letting us work with dividing these numbers. So let's multiply it out. Let's see, 5i times 2 would be 10i. And then 5i times -3i would be -15i squared. And if we look at the bottom, if we follow the rules, that problem comes out to 13. If you remember before, when we multiplied a number by its complex conjugate, what happens? So what we're going to end up having here, we're going to convert this I squared into a -1. So we end up with 15 plus 10I over 13. This is a solution. It looks kind of ugly. You could also write this as 15 over 13 plus 10 over 13I. This is technically more correct because you've got A plus BI. So this is a better form than this, though I understand if you end up here. So let's take a look at C. Maybe you have some more space and I can work this out and make it look a little prettier. Let me, I guess, put it underneath B. So B's here, and we'll start C here. So I've got 5 plus 2I over 3 minus 4I. And I'm going to multiply it by the complex conjugate of my denominator, so it'll be 3 plus 4I over 3 plus 4I. All right, so this is where it gets to be a slight bummer, only because it's going to take up a little bit more space than we'd prefer. So 5 times 3 will be 15. Let's see, 5 times 4I will be 20I. We've got 2I times 3, so plus 6I. And we've got 2I times 4I, so that's 8I squared. And I'll go ahead and multiply out the denominator just so you can see how the process works all the way through. 3 times 3 will be 9. 3 times 4I will be 12I. Negative 4 times 3, negative 4I times 3 will be negative 12I. And then negative 4I times 4I will be, will be negative 16I. So we're going to collect all of our like terms and see what's going on. So let's see. The 8I squared, this becomes 8 times negative 1. So this becomes a negative 8. 15 minus 8 will be 6. And then 20 plus 6 will be 26I. On the bottom, these two 12i's cancel out. This minus 16 becomes a plus 16, and 16 plus 9 is 25. So this looks familiar, and again, if we've got imaginary numbers, we really should have it in A plus BI form. So I'm going to split it up into 6 over 25 plus 26 over 25I. I know it seems kind of pedantic to break it up like that. Mr. Clark, why'd you bother doing it? And it really is just to keep it in the proper algebraic form. So here is C. Let's go ahead and do one more. We can take a look at D. And I guess I will do it. Let's see if we can scooch over to the side this way so we've got a little bit more room. All right. Now this one looks a little bit uglier. And I'm going to solve it the way that I learned, which is when working with these to turn this, well, you know what? I'll do it a way that's probably more familiar to you just to make your life a little bit easier. So put D here. Our numerator is 1 minus I. Our denominator is square root of 3 plus 4I. To solve this, we're going to need to multiply by the complex conjugate of our denominator, which will be times the square root of 3 minus 4I and the square root of 3 minus 4I. Now, this is going to be a little bit ugly in the interim, but that's okay. That is allowed to happen, so don't worry about it. Okay, 1 times square root of 3 will be the square root of 3. 1 times negative 4I will be negative 4I. Negative I times square root of 3 will be plus I root of 3. And negative I times negative 4I will be positive 4I squared. We'll deal with combining the like terms in a minute. Let's look at the bottom now. Square root of 3 times square root of 3 will be 3. Square root of 3 times negative 4I will be 4 roots of 3, 4I roots of 3. And then we'll do, nope, no, I got myself mixed up. I'm trying to do too many things at once. 3, root of 3 times negative 4i will be negative 4i roots of 3. Then we'll do positive 4i roots of 3. And then we will do negative 16i squared. So it looks messy. Let's kind of see what goes together here. My goodness. So it looks to me in the numerator, there's really not too much we can do. We can put together the beginning and the end. So this I squared becomes a negative 1, so this becomes a negative 4. So we can put the square root of 3 and then minus 4 together. And then we will add our I component, which would be negative 4i plus I roots of 3. Or we can do it this way, negative 4 minus square root of 3i. So we can keep it in a nice form. So again, what I did, this I squared becomes a negative 1. So this becomes a negative 4. So I did 3 minus 4 together. What's in the middle here? I've got an I can factor out, so I put it at the end, which leaves me with a negative 4 minus a root of 3. So it was just GCF and combining like terms on that one. If we look at our denominator, we're going to do the same thing with this I squared. It becomes a negative 1. So it becomes a positive 16. And then 16 plus 3, that'll give us 19. And the negative 4i root 3 and the 4i root 3 cancel each other out, and we just get that nice 19. Now, is there a whole lot more I can do here? The answer's really no. I don't have any common factors here, but look at the form. It's not the nice form. It's not the a plus bi. So I'm going to move it over to a plus bi. It's going to look a bit weird, and that's okay. I've got root 3 minus 4 over 19. Okay. And then I've got plus negative 4 minus root 3 over 19. And that's going to be my I value. So you can see that these can take up a relatively significant amount of space, but as long as you stay organized, it's really not too bad. One of the key ideas here that was in multiplication, but is really, really important, is that I squared is equal to negative 1. If you remember that, a lot of this stuff cancels itself out. Now, if you end up with funky fractions and you end up with roots and fractions, really don't worry about it. Just leave it how it is. That's the way it's supposed to look.